Good evening. I will be discussing relations and their properties, but in this video, I will discuss definition and example regarding relations. In the next few videos, I will discuss their properties like reflexive, symmetric, antisymmetric, transitive, and lastly, combining relations. So what is a relation? A relation between two sets is a collection of ordered pairs containing one object from each set. If the object X is from the set and the object Y is from the second set, then the objects are said to be related if the ordered pair X and Y isn't in the relation. So I'll be giving this a graph. This is a figure, relation, and a function. So what are the difference between the two? So a function can be a relation, but a relation can never be a function. Upon knowing this, we can say that a function is a subset of relation. As been discussed in the previous chapters, we know that a function is a one-to-one and many-to-one correspondence, while a relation is many-to-many and one-to-many correspondence. Okay, so going to the next slide. So let A and B be sets. A binary relation from A to B is a subset A and B. So what is a binary relation? A binary relation represents relationship between the elements of two sets. To further understand, let's give an example. So binary relation, we can let A be the name of people, B cell phone numbers of each people, L is, so we can say that L is a set of A and B such that A is in A and B is in B. Thus compares, or thus L is a binary relation. So I have an example here. Given A there's an A that has an element of A, set A of 0, 1, and 2, and set B of A and B. Then set of 0, A, 0, B, 1, A, 2, B is a relation from A to B. So I have a question here. So is 0 related to A, 1 related to B, and 2 related to A. So how do we solve this kind of problem? So for me, I'm going to solve this approach by using a mapping method. So how do we use mapping method? Just put A here and B here. So just put the elements here, this and this here, A at A 0, 1, and 2, and B A and B. So upon doing this, so let's look at this kind of set. So 0 A, 0 and B, 1 and A, so I'll be using a different color. So 1 and A, and 2 and B. 2 and B. So going to the question, is 0 related to A? Let's look. So we can say 0 is related to A, so thus saying this one is check mark. So is 1 related to B? Let's look at 1. Where is 1 related? 1 is related to A and not from B, so it's a cross mark. So next is 2. Is 2 related to A? Small a. So looking at the map function, so looking at the mappings, we can say that 2 is only related to B and not from A. So they are not related to each other. So thus we can say only 0 is related to A. So next slide. So definition 2, a relation on a set A is a relation from A to A. So to further understand, I'll be giving an example to this. Okay, so for example number 2, let A be the set of 1, 2, 3, and 4, which ordered pairs are in the relation R of A and B, where A divides B. So what does it mean by A divides B? So B all over A. So the condition of the quotient of B over A, we can write condition positive integers. Okay, so let's put R here. So do we know what ordered pairs must be here? Okay, so let's start with 1 as A. So okay, so let's put A first, A and B. So let's put 1 first, start 1 comma 1. So is 1 comma 1 being included in R? Yes, because the quotient of 1 over 1 is 1. As well as with 1 and 2, quotient 2 over 1, 2. And as well with 1 and 3, and also 1 and 4. So we can write it here. So 1 comma 1 comma 1, 1 comma 2, 1 comma 3, 1 comma 4. So next, we already know that 1 comma 1 is already included in our in the set, so we can already say 2 comma 2, 3 comma 3, and 4 comma 4 be included. Why? Because the quotient of 2 over 2 is 1, quotient of 3 and 3 is 1, quotient of 4 and 4 is 1. So type it here, 2 comma 2, 3 comma 3, 4 comma 4. Next, let's go to A is equals to 2. So when A is equals to 2, is 2 and 3 be included in the set? No, because the quotient is 3 over 2 and it only requires positive integers. Next, 2 and 1. Let's go to 2 and 1. 2 and 1? No, because the quotient is 1 over 2 or 0.5. Next, is 2, 4 be included? Can 2, 4 be included in the set? Yes, because the quotient is 2. So we type it here. 2 and 4. Next, we go to 3. So is 3 comma 1 be included there? No, because the quotient is 1 over 3. How about 3 over 2? No. Why? Because the quotient is 2 over 3. Next, 3 and 4. No, because the quotient is 4 over 3. So let's look at when A is 4. So 4 comma 1. No, because the quotient is 1 over 4. Next, 4 over 2. No, also because the quotient is 2 over 4 or 1 half. Next, 4 over 3 or 4 comma 3 rather. Can this be included? No, because the quotient is 3 over 4. So the answer in example number 2 is R. That is the set of 1 comma 1, 1 comma 2, 1 comma 3, 1 comma 4, 2 comma 2, 3 comma 3, 4 comma 4, and 2 comma 4. We are done about the definition of and examples of relation. In the next video, I will be discussing the first property of relation, which is reflexive relation. Thank you.